When it comes to protecting cash and assets, it's a question of always being one step ahead of the criminal, a criminal who won't think twice before putting the lives of innocent people on the line. In 2013, a new threat to the UK's network of cash machines arrived on our shores, when ruthless gangs that attack ATMs by injecting and igniting explosive gas are increasingly putting lives at risk as they aim to get their hands on the cash inside. While banks and other ATM operators are coy about just how frequent such attacks have now become, they are thought to currently average between 1 and 2 per week across the UK.
We've managed to convict a number of offenders, and in particular one group of 5 offenders from the Merseyside area of the UK were sentenced to over 127 years for a series of 31 attacks across the whole of the country. But unfortunately, the figures year to date for 2015 are at the moment higher than it was for the whole of 2014, which is concerning for us to say that this problem is here to stay just a bit longer. We've fortunately had no fatalities. We've had injuries to the offenders themselves. We've got evidence of that, and we've seen from CCTV evidence taken from buildings that explosions have either gone off too early or even too late and cause some injuries to those offenders who were actually carrying out. But fortunately, there's been no public that have been caused any harm. However, again, back to the copycats, the copycat teams that we are concerned about. They are hitting branches and locations where there are people living above or very close nearby to where the explosion takes place, and the damage to them could quite easily be caused.
Lockpoint's original Gryphon had been developed in response to an alarming rise in the number of armed attacks on cash replenishment teams. The Gryphon combines an innovative construction using different grades of steel and sophisticated electronic interlocking system to ensure that no more than one cash drawer can ever be at risk at any one time. And its ingenious construction makes it extremely difficult for even the most determined robber to gain access, even if the entire safe is taken away. As gas attacks on the UK ATM estate gathered pace, evidence emerged that the Gryphon also offered protection against this growing threat. Lockpoint set about refining the Gryphon design to maximise its ability to stand firm in the face of a gas attack. It teamed up with world-leading explosion research and testing company Gexcon to model a range of explosive attacks.
Yes, initially we used computational fluid dynamic modelling to actually solve the basic physics of the combustion reaction inside the ATM safe machine. And following on from that, we actually looked at the blast loads and the impulse durations to actually evaluate the resilience of the mechanical connections of the safety device, the Gryphon, and that was proved successful. Following the computational fluid dynamics simulations into the blast and actually performing the finite element analysis, looking at the stresses and the strains on the Gryphon device, we identified some areas which didn't fail on the simulations, but they showed some additional stress loadings. So that information was able to be fed back to Lockpoint. They were able to add some additional resilience to even make this even more robust.
The result of this theoretical testing was a modification to the Gryphon to better anchor the device to the floor of the ATM safe. In this world, of course, seeing is believing, and Lockpoint and its partner Gexcon decided to conduct a series of further tests in the field, using Gexcon's dedicated test facility near the historic city of Bergen in Norway.
Our UK branch of Gexcon has done the first stage of this project, which is analytical work where they built a model of an ATM and they created a scenario where they fill it up with acetylene air and see what kind of forces the ATM is exposed to during an internal gas attack. We mounted some analysis equipment to it so that we can create the same scenario as described in the first phase of the project. So basically we are trying to recreate in an experimental way the analytical data we have from the first phase.
In the first instance, the GEXCON team established a methodology using a relatively weak mixture of methane and air, before moving on to a weak mixture of acetylene and air. This failed to breach the safe. The team then creates the optimum explosive mixture inside the safe, creating a homogeneous mixture of acetylene and air throughout the cavity. The result is spectacular. The safe door is blown several meters off the ATM, and the cash drawers slide out of the back of the ATM for the criminals conveniently to seize their loot and make their getaway. The team then repeats the explosion on an ATM fitted with the latest Gryphon. Once again, the result is spectacular, with the safe door being blown a full 20 meters. But inside the ATM safe, there's a different story to tell. A Lockpoint engineer uses his expertise to operate the electronic locking system.
The simulations looked at a worst-case scenario, and so did the physical experiments. We were looking at a homogeneous stoichiometric, which is an ideal mixture of acetylene and air, and we actually looked at that reaction, and it developed in the region of 15 bar locally inside of the ATM machine, and those stresses were evident on the ATM machine when during the simulations and through the validation tests as well.
Lockpoint and GEXCON then repeated this test in front of a live audience from the security industry. Once again, the damage to the ATM safe is extensive. Once again, the Gryphon stands firm. Once again, a Lockpoint engineer is able to open the Gryphon doors. The cash inside is secure.
Yes, I'm very impressed by the results. Obviously positive. The machine stayed or protected the cash, which is obviously what the criminals are after. Hopefully be a massive deterrent to them. I think now it needs to be potentially advertised on the front or on the machines that the Gryphon 3 is attached to, just to give them some indication that system is fitted to a machine. But again, a very positive outcome, certainly for this company and this device. Really, I'm really impressed with it, to be honest.
There have been other attempts to outsmart the criminals who attack ATMs with gas, including so-called gas suppression kits. However, Lockpoint's partnership with GEXCON has demonstrated that this method has the potential to cause a very much bigger explosion. This is because injecting the inert suppression gas, such as nitrogen, causes turbulence within the explosion zone, and turbulence aggravates the explosion, as these experiments show. This is an explosion using methane. And this is an explosion using the same amount of explosive gas, but with the injection of a suppressant. Depending on the exact timing of the ignition, the resultant explosion can be many times more powerful. That's why the Gryphon is the only sensible response to gas attacks.
I always believed it would work. I was certain it would work, but I must admit to being extremely nervous, but absolutely delighted. I was going to say blown away, but it's too cheap. But it was wonderful, absolutely extraordinary to see all that work, all that effort and determination that we had to solve these problems just vindicated. It's marvellous.
Lockpoint's core principle remains the same. Look after the cash and everything else will look after itself. Criminals will simply not waste time attacking an ATM fitted with a Gryphon.